Alright, let's get started with our unit test for kinematics under the course physics. Let's go. Alright, so the first question says a soccer ball is kicked straight upwards with initial speed of 8 meters per second. Assume air resistance is negligible, which means that we can have acceleration to equal g, which is the gravitational acceleration, which is 9.8, and it is towards downwards because this is where the force is. And if we take the upward direction to be positive, A would be negative 9.8. And because air resistance is negligible, we can ignore terminal velocity, and air acceleration remain constant. After how much time will the ball be moving with velocity? Okay, so final velocity is 4, and time equals to what? And all right, so 4 meter per second towards the ground, so it's v equals to -4, the opposite direction, because initially it was projected upwards. Ball was projected upwards towards the ground. As my criticism, which upward is positive, so we did, and round answers to two significant figures. All right, so we have u, we have t, v, and a. So we use the equation v equals to u plus at, and v is -4 equals u is positive 8, negative 9.8 times t, and the t that we'll get here will be our answer. So -4 equals 8, -4 equals 8, negative 9.8, negative 9.8, and for t we replace with x to get our value, and for two significant figure we give 1.2. Okay, so 1.2 would be our answer. There we go. All right, next one. Marble is rolling up a ramp. Okay, so we have a ramp here, and we have a marble here which is rolling up with an initial velocity, so u equals to 2 meters per second, and a constant acceleration. So that if this is the positive, acceleration is in the opposite direction here, and it is -2. Okay, which element correctly describes the marble at time t equals to 0.5 seconds. The marble's direction of motion is positive and its speed is increased. Again, we have to calculate the v, the final velocity, when we have t equals to 0.5, and then we can comment which one is the true. So we know that v equals to u plus at, and u is given to be 2, -2 times 0.5. So if we calculate that, 2 -2 times 0.5, we get 1, and this is positive 1. 1 positive means it is still traveling in this direction. So yeah, the marble's direction is positive and speed is increasing. No, it's not true, because the velocity is in this direction, but the acceleration is in the opposite direction, which caused the speed to decrease. As you can see, it got reduced from 2 to 1. So it's not true. The marble's direction of motion is negative. No, it's not negative. It is positive, and the speed is decreasing. This is the correct one. There we go. All right, question 3. A car is stopped at a traffic light. Okay. When the car turns green, when the light turns green at time t equals to 0, a truck with constant speed passes the car. Okay, there is a car, t equals to 0. It has an initial speed of because it's at rest, but we have a truck that it passes the car and began moving with a uniform acceleration. Okay, the car begins moving with uniform acceleration, but the truck here is moving at a constant speed. It passes the car at the exact time when t equals to 0. On the graph below, the truck is represented by the dotted line, as you can see, T for truck, and the car is represented by a solid line, C for car. How long will it take for the car to catch up with the truck? All right, so in order to catch up with in order for the car to catch up with the truck, the distance traveled by each of them must be equal. So S displacement must be equal, and in order to do so, we actually have to make two equations and find out their intersection. So for truck, it travels at a constant velocity v. So we know that the constant velocity equals to displacement divided by time. So s for this one is vt. On the contrary, for the car which is experiencing constant at a constant acceleration, we can think of an equation with t equals to 0, s, and a. And we can find the acceleration from here. The gradient of velocity time graph gives us the acceleration. So we can take a point, let's say this one, this is 30, y2 minus y1, 30 minus 0, over x2, which is 30 minus 0. So it's 1 actually. Acceleration is 1. 35, 35, yeah. So we can say s equals to ut plus half, sorry, s equals to ut plus half at squared. Now initial velocity is 0, so entire term becomes 0, so s equals to half times acceleration, which is 1, and times t squared. So basically s equals to half t squared. And we equate the, basically we equate the s here. So s equals to s, we have vt equals to half t squared. Now, what is the speed or velocity of the truck? It's 15. We can plug this one here. So we can say 15t equals to half t squared. They ask us to find how long will it take for the car to catch up with the truck. This is the value of t. So we have 15t, replace that with x, equals half x squares, x squared. So 15t equals to half t squared, get replaced with 15x equals to half x squared, and you have two values, which is 0. 0 is not, obviously 0 is not the answer. So 30 is the answer, 30 seconds. So let's put in 30. All right, next one. Okay, a zoologist collects velocity and position data for a hippo accelerating to escape a predator. The zoologist then plots the velocity v of the hippo as a function of its position x. Okay, so v as a v square. Okay, the resultant graph is a curve not linear. Based on the shape of the curve the zoologist decides to square the velocity values to create a graph of velocity square. V square is a function of position x. The resulting graph is shown below. What is the acceleration of the hippo? Or in order to do so, we have to find an equation that relates v squared with x. And as you can see here, it is this equation. So we have to find the acceleration. So if you compare this given equation with our, with the standard form for y equals to mx, where's the pen? There we go. So y equals to mx plus c. So this constant term is basically this thing, and we have to expand this. So v squared equals to v naught squared plus 2ax negative 2ax naught. So we have v squared is equals to 2ax positive v naught squared negative 2ax naught. So as you can see, this entire thing is being added or subtracted, so we can count this to be the c, and we've plot x on the x-axis, so this is x, essentially x, and we have plotted v squared on y-axis, so this is essentially works at the y, the thing that we plot on the y-axis, and this is what we can see, this is the gradient or m. So the gradient of this line will be equal to 2 times the acceleration, and acceleration would be m divided by 2. So what is the gradient from here that we can find from here? It's y2, let's say 60, minus y1, which is 20, x2, which is 5, minus 0. So it's 40 by 5, ultimately becoming 8. Let's take it out. So we have 6, let's say we have 60 minus 20, so 60 minus 20, and that is over 5. So 5 positive 8. Yep. So m is 8 and acceleration is 8 by 2, which is 4. So our answer should be 4. There we go. Okay. Velocity vector v naught has a magnitude of 2 meters per second and points right. Velocity vector vb has a magnitude of 6 meters per second and point left. Which of the following are accurate representation of these two vectors? Assume a coordinate system where left is negative and right is positive. Okay, so what do we have? We have a VA magnitude 2 points right. So VA is pointing right and VV points left. And here is also true. Okay, but the magnitude is 2, 6. So the ratio 2 divided by 6 is basically 1/3. So which means whatever scale you take, VB must be thrice that of VA. Here we have taken 1 scale, so we have 3 scale. This is correct. But what about this? We have 2 here, but we have 1, 2, 3, 4. We must have 6 here, so this is not correct. What about this? We have 2 meters per second VA. Both of them is the same. But we know that VB must be in the opposite direction. VB is left, right? So VB magnitude left, so VB must be negative. So C is our answer. So A and C is what we are going to choose. There we go. Okay, a bird is flying back and forth. Its velocity v as a function of time t is given in the graph below, where rightwards is the positive velocity direction. What is the bird's displacement del x from time t equals to 2 time 4 second. Okay, we know that the area under the velocity time graph gives us the displacement. So for time 2 to 4, we actually need to calculate this portion plus this portion. Okay, now this one is, we have a 5 length here and we have 1 length here, because from 2 to 3 we have 1. So the area would be half times 5 times 1 plus, we need to add this shape here, so we can break it to a rectangle, as you can see, of length 1 and 5. So half times 5 into 1, half is the rectangular triangle formula for finding area, times 5, which is this length, times 1. So it is basically, we have this thing twice, so we can write this twice, and we have an area of 1 length times 5 length, so 5 times 1. So we cancel this out, we get 5 plus 5, the displacement to be 10, but we have a negative here, so it is negative 10. Yeah, this is what we have. Oh, sorry. Area under the graph is basically this portion, not this one. So we only have to take once. So half times 5 plus we have 5. So half times 5 into 1 plus 5 into 1. So we have 2.5 plus 5, which is 7.5. So two significant figures. This will be our answer, right? Oh, negative 7.5. Yeah. Negative 7.5. I just told you that it was negative 10, so Similarly, it will be negative because it's on the negative side. Okay, next one. A cup slides off a 1.1 meter high table. Okay, so we have a table that is 1.1 meters from the ground, and it slides off, which means it just starts from rest equals to zero with the speed. Oh no, yeah. So this is a horizontal speed or horizontal velocity, but we have a so this is the vertical one, but we have a horizontal velocity of 1.3 towards the right, and you can ignore air resistance. What was the cup horizontal displacement during the fall? All right, so air resistance is negligible. Vertically, we have a equals to negative 9.8, assuming upward is positive. Now, we know that S is equals to negative 1.1, and if we can find the time taken that it takes to reach the ground, we can use the time to calculate the horizontal displacement later. So S equals to UT plus half AT squared. U equals 0. Cancel this entire thing out. S equals to half times A, negative 9.8, times T squared. Sorry. Times T squared. And S is what is S is negative 1.1. Negative 1.1 equals half times negative 9.8 times T squared. And we have to calculate T from here. So we replace T with X. And we find the value, find two values, and time can't be negative, so it's 0.4738. This is the time that the ball takes to reach the ground, and this is the time it has to move towards the right. Horizontal velocity 1.3. Now displacement is basically 1.3 times this velocity, which is 0.4738. So 1.3 times 0.4738 is 0.61. This is the displacement it can have horizontally, and two significant figures means we have to give our answer to 0.62. Okay, there we go. Next question. A small aircraft flies over a ramp at a constant velocity v of 50 meters per second to the right relative to the ground. At time t equals to 0, a package is released from a hatch on the bottom of the plane. The plane maintains velocity v after the drop. Observer A on the plane defines coordinate system A in the plane's reference frame. Origin OA is at the hatch and moves along with the plane. Its origin is at the hatch and moves along with the plane. Right is positive x direction, as you can see, and down is positive y direction as modeled below. But observing on the ground defines coordinate system B in the reference frame. Its origin OB is on the ground directly below the package's position at time t equals to 0. Right is the positive x direction, and up is the positive y direction as modeled below. On the axis below, model the package's vertical velocity as a function of time using the coordinate system A, using the plane's reference. G is 10, air is negligible, and we have to do the same for B as well. We have to model the package vertical velocity as a function of time using the coordinate axis B in the ground's reference frame. All right. So vertical velocity. Initially, it starts from rest. Vertical velocity, it starts from rest. So velocity would start from zero without any doubt. Now, so start from released from hatch velocity, and only have we have a horizontal velocity here, so it's moving downwards actually. So it will be positive for a. For a, it will be for a, because they have defined downward direction to be positive, and the object is moving downwards. Now, what is acceleration as a function of time? We know that v equals to u plus at. So u equals to 0. Cancel this out, equals to a times t. Now, a is 10, which they have said, and acceleration is in the same direction as the positive direction downwards. It's positive 10, so v equals to 10t. So which means, for let's say we take 5, huh? So for 5, we have a v of 50. So we plot this out. For 5, we have v of 50. We have the same magnitude, but for this one, we have the opposite one. For 5, we have negative 50. That is because for observer B, upward direction is positive, and when ball falls down, it is following the counter direction or the negative direction, and hence it is negative. Okay, so a ball is kicked at an angle with negligible air resistance as seen below. Point P is at the ball's maximum height, where the vertical component of the velocity is 0. Which direction is the ball's vertical Which direction is the ball's vertical velocity at point P, the peak of the trajectory? Well, the vertical velocity always is down, regardless of where it is. No vertical velocity? No. Yeah, no vertical velocity. Because which direction is it? Okay, so yeah, vertical velocity, not vertical force. At point P, no vertical velocity, v equals to 0. There we go. A batter hits a baseball at angle theta above the horizontal. The ball leaves the bat at speed v1. The ball is caught by another player a horizontal distance d from where it was hit as modeled below. The batter hits a second ball at the same angle theta as the first, and this time the ball is caught at a horizontal 3d, a distance 3d from where it was hit as modeled below. What is the speed v2 of the second ball as it leaves the bat? Assume air is negative and the ball is caught at the same height from which it left the bat. So s equals to 0 basically. Displacement, vertical displacement. We have to make some calculations. We have to find v2 in terms of v1 using known information that we have. So if you resolve this, so we have v1 cos theta and v1 sine theta. So thinking vertically, u is v1 sine theta, and s equals to 0, and because air resistance is negligible, a equals to negative g, as if taking upward direction to be positive. Okay. What else do you know? Do you know time? Do we know what else? SUV. Yeah, V. Now, because the ball catches at the exact same vertical height and air resistance is negligible, so the same magnitude of the speed will be there except for the change of direction. So V would be actually negative V1 sine theta. Now, we know that V squared is equals to U squared plus 2AS. So V is negative V1 sine theta squared goes to U squared V1 sine theta. V squared equals to U squared plus 2 into A to So S equals to 0, this is true, but we don't want to take S here. We want to take, we know that we want to take time, T. We want to take the time T, and we want to find an equation that has T in it. So it's V equals to U plus AT. Why? I'll tell in a moment. So negative V1 sine theta equals to V1 sine theta negative GT. If you take this thing here, it becomes negative 2V1 sine theta divided by negative G equals T. T becomes 2V1 sine theta over G. Now what you can do is, because we know that the horizontal and vertical it's the same time for the ball to come here. The same time is taken by both the horizontal and vertical. So we have considered vertical direction or vertical velocity here. Now we can use this time to calculate to put into the horizontal equation, and air resistance is negligible. So we have a constant horizontal velocity of v1 cos theta. So v1 cos theta equals displacement, horizontal displacement, which is d, d divided by time taken. Speed equals to distance divided by time taken. Now, this is the time. So we can plug this one here. v1 cos theta equals to d divided by time, which is 2v1 sine theta. And because this thing is divided by g, it becomes multiplied above, reciprocal, 2v1 sine theta. Now, we keep it as it is. We now consider this scenario where we have exactly similar thing. So we can write negative v2 sine theta equals v2 sine theta negative gt. And so from here, t would be equal to 2v2 sine theta divided by g. Because vertically, it's the same thing, except for the horizontal distance. So for horizontal distance, we have v2 cos theta, speed equals to distance, which is 3d, divided by time taken, which is this thing. So, which is g comes here, and we have 2v2 sine theta. Now, what we can do is we can use this equation to make d the subject, because it's the same d. And if we do so, we will get the relationship between v1 and v2. So v1 cos theta, when we multiply this, it becomes v1 squared 2v1 squared cos theta sine theta divided by g is what we get d. v1 cos theta gets multiplied with 2 v1 squared, and sine theta divided by g is d. So if we plug this one here, what and we also get here v2 squared 2v2 squared cos theta sine theta divided by g equals 3 times d, and d is this thing, which is 2 times v1 squared cos sine theta cos theta. Divide by g. So 2 times v squared sine theta cos theta divided by g equals to 3d, 3 into d. Now d gets replaced with 2v squared sine theta cos theta divided by g. Now as you can see here, what we can do is we can cancel similar things. So both sides 2 cancel out. Cos theta, sine theta, g, g. What are we left with? We're left with v2 squared equals to 3 into v1 squared. So v2 is basically root 3 times v1. So B is our answer. There we go. Next question. An object speeds up to the right. Okay, it speeds up to the right, and acceleration. So which means what? Its velocity is in this direction. Acceleration is also in this direction. And because the acceleration is positive, the velocity should also be positive. Because an object speeds up to the right, and acceleration versus time graph of the object's motion is shown below, which velocity versus time graph correctly represents the object's motion. And the acceleration is 4. Positive. It's positive. Here we have positive gradient. Here we have constant velocity. Here we have a turn. That's not true. And here we have negative. This is not true as well. For this one, this is true. What about the acceleration? 28 divided by 4. 28 divided by 7. Magnitude is matching. So is the direction. So our answer would be A. Okay. So a ball is thrown down from a bridge. So we have a, let's say we have a bridge here, and we have a ball here, and it is thrown down. At time t equals to 0. Which of the following graphs represents the velocity of the ball as a function of the time? Assume upward is chosen as positive direction and air resistance is negligible. Okay. Now we don't have any change in the direction because it's thrown down from a bridge, and it is just in the negative direction. So this is not correct, and it doesn't have any positive velocity. It's thrown down. It's not thrown upwards. So this is correct. If it was released from rest, but it is thrown down, so D would be correct. It has some velocity in this direction because they didn't say u equals to 0. It's just released from the bridge, but it is thrown down with some velocity that you push. So that's why our answer would be D. Okay. The motion diagram below represents the motion of a dog. The first dot shows the dog's position at time t equals to 0. This one. The time interval between dot is 1 second. During which time interval does the dog have the greatest average velocity? Greatest average velocity. As you can see, the velocity is getting decreased with the progression of time, so which means it is having a deceleration. For, from time, these are not times. This is t equals to 0. This is t equals to 1. This is t equals to 2. This is 3. This is 4. 0, 1, 2. Because it says the first dot shows the t equals to 0. So for from 0 to 2, or 1 to 3, or 2 to 4, so 2 to 4, it must have greatest average velocity. Definitely not 2 to 4, because 2 to 4 just only have 3 3 meters. The time interval is the same. It's 2, it's 2, it's 2. So the largest distance that we will cover is the one that gives us the greatest average velocity. So here we've covered only 2 meters from 2 to 4. So 2 to 4, as you can see, is just 2 meters. From 1 to 3, so from 1 to 3 we have 1, 2, 3. But from 0 to 2 we have, as you can see, we have a 1, 2, 3, 4, 5. So definitely A is our answer. Last question. A sled slides down a 50-meter long hill. Okay, so you have a 50-meter, okay, 50-meter long, not height, 50-meter long hill that makes an angle 60-degree with the ground. What is the magnitude of the sled's horizontal displacement? This thing. A sled is a sled that slides down a 50-meter long hill that makes an angle of 60 degree with the ground. What is the magnitude of the sled's horizontal displacement? This thing. So we have adjacent over hypotenuse, which is cos theta. We know that cos theta is equals to k adjacent over hypotenuse. So it's cos 60 equals adjacent, which is horizontal displacement. Let's say it's S times the h, divide by h, so h is 50. So 50 cos 60 is the answer. We don't need this. 50 cos 60, right? So we have to change this thing to decrease. 50 times cos 60. It's 25. Decrease 25. So our answer is C. And that's it. That marks the end for this unit test.